All right, so today we're going to talk about distance and midpoint. Okay, distance and midpoint. And we're going to look at if we have a coordinate plane, right? And we have a couple of points, let's say there and there. All right, let's say this one is 5, -2. And let's say this one is -2, +4. Okay. There's a couple of things that we can decipher from this to help us understand how do we calculate, let's say, between these 2 points, the midpoint, as well as just the distance between the 2 points. So I'm going to start actually with the distance first. And if we look at this distance between these 2 points, okay, how would we calculate that? We have these points, but how exactly do we get this distance right there? Well, we can create a right triangle by knowing this distance here and by knowing this distance here. That can actually tell us the two legs of a right triangle. And if we remember the Pythagorean theorem, for any right triangle with legs A and B, the hypotenuse can be calculated. The hypotenuse squared is equal to A squared plus B squared. Quite literally, where this comes from, in any square, obviously the length and the width are exactly the same, right? So if you were to draw a square here with A, that doesn't even look like a square, but kind of bear with me here. This would be A on this side, A on this side. So the area here would be A squared. This area here would be B squared. And then this area here, the hypotenuse, this area here would be C squared. And so what was discovered a long time ago is that the area of this square and the area of this square, those two added together equals the area of this square. And so what that allows us to do, and that's what this says right here, the area of C plus the area of A plus the area of B, because of length times width, that's where the squares come from. But essentially what this allows us to do is then calculate C. If I take the square root of both sides, the square root of C squared is C. And so the square root of A squared plus B squared is this distance here. So knowing that, we can calculate this distance here. So the first thing we have to do is figure out, okay, what is this distance and what is this distance? We get those two numbers, we can plug that in here and find this distance. So from here, we know that our vertical distance, right, if we look at just the y-axis here, okay, y's are going to be my second number. We know we're up at 4 here, and then down here, we know we're at -2. Okay, so to go from -2 all the way up to this point here, this distance here, -2 to +4, 1, 2, and then 4, this whole distance here is going to be 6. Okay, and then from here, if we look at the x-axis, those are going to be the first two numbers here, right? If we look at how far here this side is, We're here also at a -2, and we're all the way out here at 5. So what's this distance here? This distance is 7. 5 here, and then 2 there. That's 7. So now we can calculate this distance. That side there, C, is equal to the square root of 6 squared plus 7 squared. So that's 36 plus 49. The square root of that is equal to that line. So let's go ahead and just throw that into the calculator. 36 plus 49, that equals 85. So C is equal to the square root of 85. Now remember that we know how to find an exact value here. I know that the square root, or that 9 squared is 81, and 10 squared is 100. So we're going to be somewhere in between there. So I can kind of define the roots here of 85. And 85 is 5 times 17, which are 2 primes, and I don't have actually a clean square root inside the 85. So this can just be written as the square root of 85. Excuse me. As far as the distance is concerned, square root of 85. All right. The next thing I want to do is I want to find the midpoint on here. So I'm going to rewrite this. We've got a lot written on here. So let's kind of draw this again. Okay. We've got -1, 2, +4. And here we've got 5, -1, 2. All right. And now what we want to do is we want to try to find the midpoint between these two, somewhere in here. It's probably going to be the first quadrant right there. Okay. What we notice, if we draw the same right triangle here that we had in the first one, okay, and we already know that this side here is 6, and this side here is 7, okay, we can say that halfway between here, okay, 3, right, a distance of 3. We have 3 there, and we have 3 there. That would be the halfway point. We can kind of extend that out. Then we could do the same thing here. The half point of here would be 3.5. 3.5. 3.5 to the midpoint, another 3.5 to get there. So if we combine these two ideas, we know that we can find our midpoint. So here, we know this point here is 5, -2, and we know this point up here is -2, 4. So to find this point here, I'm going to come down 3 to get my y midpoint. So this is at 4. If I come down 3, this would be a +1. Okay, so that would be my y point. From 1, if I go down 3 more, I get to -2. And that's the whole line there. All right, same thing on the x. I can either start here or I can start here. Let's start here at the 5. We're going to come this way 3.5. So if I come 3, that would give me 2. If I come another half, that would give me 1.5. And it works the other way too. If I start here, which would be -2, and I go this way 3, then I have +1, go another half, +1.5. Then here, if I'm starting at -2 and I go up 3, that would give me 1. So the midpoint is 1.51. That's this point right there. All right. You can look at this in terms of an equation too. If we look at what we just did, right, the midpoint, we could say this is x and y. And what we did here was we took the difference of our two x's. Our x's here are 5 and -2. Um, is it the differences? Let me think about this. I think it's the difference. Well, this would give me 7, and then divided by 2 would give me 3.5. So that's not going to give me the point. I think I add them straight up. So 5 plus -2. Yes, because that would give me positive 3, and I divide that by 2 to get my 1.5. Then here on the y side, I do the same thing. 4 plus -2 divided by 2. Positive 2 divided by 2 is 1. Okay, so then the formula is the first x point plus the second x point divided by 2. And then the y is the first y point plus the second y point divided by 2. And this is what's known as the midpoint formula. All right, so let's work some examples, kind of understanding this stuff. All right, remember we're using the Pythagorean theorem to calculate that other side, and then the midpoint formula. And I'll just kind of keep this on hand. All right, so let's look at, we want to find the midpoint between 2, 6 and 7, 4. Okay, let's go ahead and make a graph. You don't have to make a graph, but I think a visualization of what's going on always makes it easier to understand. All right, let's look at 2, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 7, 8. All right, so 2, 6. 1, 2, 1, 2, 3, 4, 5, 6. Okay, right there. 7, 4. 5, 6, 7. Good. And then 4, 1, 2, 3, 4. All right. So we want to find the midpoint between these 2 points. It's going to be somewhere there. All right. So just take our midpoint formula, which we can do, but let's think about this logically. I think as we learn this, it's probably best to look at it logically. So right here, if I say what my 2 points are, 2, 6, and 7, 4. If we look at this point here, this is your 2, 6. Your x is 2 and your x is 7, right? So what's the distance between those two? That distance between the x's is this distance right here. You're going from 2 to 7. That's a distance of 5. Okay? And then the same thing here. If I go on my y, I start at 6, right? And I'm going to come down to 2. So I'm sorry, come down to 4. I'm going to come down to. So that distance is 2, but I'm coming down to 4. All right, so I'm coming down 2, or from 4, I'm going up 2 to 6. And then from here, from 2 to 7 is 5, or from 7 down to 2 is 5. So those are the distances there. So we could very easily calculate that distance, but I want to look at this logically. So my y actually would be pretty easy because this is 2. Obviously, it's only 1 in between. So if this y here is 4 and this up here is 6, what's in the middle is 5. So the y part of this is really easy. That's 5. Now, what's the x part here? Okay, it's between 2 and 7. So half of 5, which is the distance there, is 2.5. So from 2, if I go 2.5, that's 4.5. So this would be 4.5 or 4.5, either way, for the midpoint. Okay. All right, I'm going to rework that one, except I'm just going to use the formula. So you can kind of see that the formula gives us the same thing. You can solve it either way. 2, 6 is the first point, 7, 4 is the second point, midpoint formula, or we add the x components together and divide by 2. That's my x portion, and then we take the y components and divide by 2, and that's the y portion with the comma in the middle. And I know I've been drawing this wrong. This needs to have a bigger parentheses to show that this ordered pair exists as comma separating the two x coordinate, the y coordinate. Okay, so in this case, my x's are 2 and 7. So 7 plus 2 is 9, divided by 2, and then I have my y's. 6 plus 4 is 10. 10 divided by 2. Okay. 9 divided by 2 is 4.5. 10 divided by 2 is 5. And so you can see, we can look at it graphically, see what's going on. You can also solve it using the formula. And this kind of shows you a little bit of the power of algebra, that we can take some of these visual concepts in graphs and we can figure them out through a formula instead of having to draw everything out. So that's definitely one of the powers of having of the discipline of algebra. Okay, so now let's do some let's do a distance scenario here. So we're going to do 2, -1, and then the other point is going to be 3, -8. 2, -1, 3, -8. I'm going to go ahead and draw a graph. We're going to do distance here. Okay. 1, 2, 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7. 3, 4, 5, 6, 8. 4, 5, 8. All right. My first point is 2, -1. 1, 2, -1. You are right there. And my second point is 3, -8. 1, 2, 3, -8. All right, so we want to know this distance right here. Okay. So we can make a nice little right triangle. Okay. Where this distance here is at, let's see, this is at 2, this one's at 3. So that is a distance of 1. And then my y here, this is at -1, this is at -8. So that distance is 7. All right, so to find the hypotenuse, remember this square here, and this little tiny square here equals the same area as this square here. So the area formula of this is length times width. It's a square, so all four sides are 7. So that's 7 squared. And then all four sides of this little one here with one side being 1 is 1, so the area would also be 1 times 1, or 1 squared. And then that would equal this, c squared. Or, as we saw before, a squared plus b squared is equal to c squared. All right, so this becomes 49 plus 1 is equal to c squared. I'm going to switch the orientation here. So this is going to be c squared is equal to 49 plus 1. And 49 plus 1 is 50. So we have c squared is equal to 50. Okay, and then to solve for c, I'm going to take the square root of both sides. The square root of c squared is c. And 50 underneath the square root, 50, if I do a factor tree, is 5 and 10. 10 is 2 and 5. So here I see that I have two 5s. 5 times 5 is 25. 25 times 2. So 50 is 25 times 2. And I'm using 25 because it's a perfect square. Now I can split it up. Square root of 25 times the square root of 2. Square root of 25 is 5. C is 5 times the square root of 2. All right, so hopefully that kind of visually shows you where everything kind of comes from. That was always super helpful for me in learning math, rather than just chugging through formulas was very uninteresting for me personally. So if we look here, 2, -1, 3, -8, we'll just use the formula. C is equal to a squared plus b squared. So how do I get these sides? And that's where the formula here is actually going to have to be a lot more complicated, because we need the distance a, we'll call that the x distance, and the distance b the y distance, which is this 7 and this 1, right? To get 7 squared plus 1 squared. So to get that, we actually have to find the differences between the two x points and the differences between the two y points. So this ends up being x2 minus x1 squared. I almost divided it by 2, but that's not what we do. And then here, y2 minus y1. Okay, so the square root of x2 is 3, minus x1 is 2 squared, plus y2 is -8, minus y1 is -1. All right, and then that squared. Okay, 3 minus 2 is 1. We have 1 squared. Then here, -8 minus -1. That's -8 plus 1. -8 plus 1 is -7. Quantity squared. Remember to keep those parentheses there. So everything in the parentheses gets squared. So that's the square root of 1 squared, which is 1, plus -7 squared, which is -7, times -7, which is positive 49. And of course, that is the square root of 50. And we've already done the radical expression there. That's 5 times the square root of 2. All right. So this is actually the more robust formula. Let me adjust that. For the distance formula here, these just kind of need to be rewritten. So that distance there is going to be x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Square root of that. And then the midpoint is going to be x1 plus x2 over 2 comma y1 plus y2 over 2 for the x and the y coordinate of the midpoint. Very good. All right. So let's do one more example. Let's do -6, -6, and then -6, -10. So we'll look at both the distance and the midpoint here. Since these are all negative, this is going to be third quadrant. This is going to be third quadrant. I'm just going to draw the third quadrant. -10, and then 1, 2, 3, -10 here. Okay. So the first point is going to be -6, -6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right, right there. And the next one is -6, -10. So it's literally the same place there, but comes down here. All right. Okay. All right, so this distance here actually be really easy to calculate because if we look at this distance here, that is the hypotenuse. There is no x distance. They both have -6 here as the x coordinate. So if you look at the distance formula, right, x1 is -6 plus x2, that's -6 divided by 2. Sorry, the distance one. Square root of x2 minus x1. So x2 is -6 minus x1, -6. And then that quantity squared. So -6 minus -6, and obviously you're going to have the y part over there. But these two are going to cancel each other because minus a negative right here is a plus. So this ends up being -6 and then plus 6 quantity squared. So -6 plus 6 is 0. 0 squared is just 0. So what you're left with is the y part. Y -10 minus -6. And then that quantity squared, which is just going to be this here. So this goes from -6 here down to -10, 7, 8, 9, 10, 1, 2, 3, 4. This is literally 4. That's going to be the distance. But if we look at the formula, we know that the x is 0. We just calculated that. Now let's look at the y. -10 minus -6 squared. Okay, I'm going to drop the 0 out since we don't even need it. -10 minus a negative is a plus. So this is -10 plus 6 quantity squared. -10 plus 6 is -4. Okay. -4 squared is +16. Square root of 16 is 4, which is obviously what this is. So that was pretty easy. So let's look now at the midpoint. Okay. So the midpoint's a little different. The midpoint is going to be if we remember, let me do a different color here. X1 plus x2 divided by 2 for the x coordinate, and then y1 plus y2 divided by 2 for the y coordinate. So this is -6 plus -6. That's going to be -12 divided by 2. And then here, y1 -6 plus -10. It's going to be -16 divided by 2. All right, so the x part here is going to be -6. That's -12 divided by 2. And the y is going to be -8. And that is, in fact, the midpoint here. The midpoint on the x is going to remain on -6. And then here, the midpoint on the y, this is 1, 2, 3, 4. So 2 would be the midpoint right here. And that's between -6 and -10. That's going to be -8. So our distance is 4, and our midpoint is -6, -8.